Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, my name is Ahmad Farhan bin Nasrizam and my partner here, Loman Nur Hazim bin Ahmad. So, we are excited to present our IOT mini project, the Smart Mosque Management System. So, we basically design a system that brings modern technology into sacred and essential space, the mosque. So, here's a quick overview of what we'll be covering. We'll start with a brief introduction, dive into the core design of our system, and end with a live demo to showcase how everything works in real time. So, a little bit about the project background. Mosques in Malaysia are more than just places of worship, they are community hubs. Yet, many still rely on outdated, manual systems to manage their environment. That means light left on unnecessarily, poor air circulation, and high electricity bills. So we thought, what if we could make the mosque smarter? Our system automates key environmental controls like temperature, lighting, and even the roof, making the mosque more comfortable and energy efficient. Now, let's talk about the problem statement. So these were the three main issues we identified. First, too much electricity is wasted because systems are not switched off when not needed. Second, there's no efficient way to monitor the environment. And lastly, everything's done manually. No centralized control, no automation. So now let's talk about the objective. We set three clear goals. First, to cut down electricity usage. 2, to enhance the comfort and air quality inside the mosque. And 3, give administrators a simple, centralized way to control everything. And how's that work? So, the process will be, our project went through three main stages. First, we brainstormed and designed the system from scratch. Then we built a working prototype using ESP32 and several sensors. And finally, we tested it to evaluate how effective and functional it really was. Here, you can see how different users interact with the system. So the admin or the mosque community here can monitor data and control systems like lights or roof through a web app. Meanwhile, sensors feed the data into the ESP32 in real time. It's a smooth loop of detection, decision, and response. Now, let's take a look at the block diagram. Basically, this is the heart of our design. And at the center, we have the ESP32, a powerful microcontroller. So it receives input from multiple sensors like the temperature, humidity, light, and even IR. So based on the data, it controls outputs like the servo motor for the roof and LEDs for lighting. And all this connected to Firebase and a simple web application interface. So we also reviewed existing research on smart environments, IoT integration in religious or public spaces, and energy saving systems. Most of them focused on large-scale buildings, but there was a gap. Mosques were often overlooked, so this gave us a unique angle. So, this project isn't just about tech, it's about impact. We are improving sustainability in religious spaces, and we are making mosques more comfortable for worshippers. We are showing how IoT isn't limited to factories or smart homes. It can also benefit our spiritual and community life. So, for the fun part, the demonstration, I'll pass over the presentation to my friend Lokman to do the demonstration.
Assalamualaikum everyone and very good day. My name is Lokman Ahmad. So I'll be demoing our project of Smart Mosque management system. So these are the replica for our mosque. So on this mosque we have a multiple sensors lah. So we have the rain sensors, and then we got the servo motor here, and then if you open up this, we have a more more sensor under here. So here we can see there is multiple. So here we have a DHT11 sensors, and here are the IR sensors, and here we have the LDR sensor to capture the light, and we also have a LED here, red, yellow and green too. Alright, so this are our database lah for our ESP32. We have the real-time database that will store all of the reading of our ESP32 sensors. So we got the control here, which to control of the actuator on our ESP32, and then we have the current, which store all of the sensor data lah, such as the humidity, lights, rain, temperature, and also the visitor. Okay, so this is our dashboard, the front end for our system. So on the first layer here, we can see this is the sensor data that we grab from the Firebase. We got the temperature, the humidity, and the lux. On the second layer, we have the alert status for. So here, right here, it's showing the temperature status. If it's between 30 to 35, it will be showing too hot. If it's between 25 and 30, it will show comfortable. If it's from 20 to 25, it will be too cold. And then this is the rain status. It will show if it's rain, it will showing raining. If it's not rain, it will show no raining. And this is the light status. So if it below 1000 lux, it will show it is dark. If it's between 1000 to 1500, it will show dim. And if it's between 2000 until 3000, it will show good. And this is the visitor status. It will show whether if there is a visitor or not. And then this is on the next layer is this is the control layer. So this is where we control whether we want to automate it or not. So light mode here, if the visitor are present and the dark and the light status is dark, the light will automatically be on. Then on the next layer is a rain based auto control. So if it's raining, the roof will be closed. If it's raining, the roof will be closed. If it's not raining, the roof will be open. Right. Alright. Now let's test all of our sensor whether it's working and reacting fine. So first thing, let's try the rain sensor. Let's put some water on the rain sensor now. So remember, if it's raining, the roof will close. So just like that, the roof will be closed. So now let's test. So from here also we can see it is showing rain alert. So now let's test the other sensor. Alright. So now let's test the light sensor. So currently the light are around 1000. So if it's the light, if it's less than 1000 and there is a visitor, it will power on the LED. So right now it is more than 1000 and the visitor are currently present. So let's lower the light here. Let's close it and see whether the LED will power on. So the LED is power on now lah. Right, so if I lift my hand, the light will off now. Right, so I believe that is all from me. Thank you everyone.